Hi guys, so today we'll be solving Leetcode to find the closest palindrome. So given a string representing an integer, we need to return the closest integer and not including itself, which is a palindrome. If there's a type, then we return the smaller one. So let's take a look at this example. We are given a integer 1 to 3 and we return 1 to 1 because basically this is a palindrome. Palindrome is a number that if you read it backward, then it's the same number, right? So 1 to 1, if you guys read it backward, then it's still 1 to 1. Okay, so for 1, then it's 0. Okay? Basically, then any number that has a length that's smaller or equal to 1, then that number is a palindrome, right? So this question is kind of tricky, and basically I think this is one of the harder, right? If you see at the acceptance rate, it is relatively low, and the acceptance rate is actually 20% as of yesterday, I do believe. So the solution for this question is there's basically math solution, binary search solution, but the math one is actually more efficient, but it's kind of the implementation part is actually really long and tedious. I've read before solving this question, and I've read through the discussion tabs a lot to basically build the enough intuition to solve this problem. So okay, so let's start solving the problem. So the first question is, how are you guys going to generate a sequence of palindrome number, right? So basically a palindrome number is a number that reads the same backward as it is forward, right? So if we take a number and we copy the first half of the number and we paste it, right, then we form a palindrome, right? So we basically can do that if you want to like generate a sequence of palindrome, right? So now let's take a look at this. We basically iterate from 0 to whatever it is, right? So 0, as I've previously said, then a number that has a length smaller or equal to 1, right? Basically that number is a palindrome. 0 is 0, 1 is 1, all the way to 9, and now we come to 10, right? So we take the first half of the number and we just mirror it, right? Now we have 11, and that 11 stay up until 19, right? So now we have 20. That's just, if we take this guy and we just mirror and paste it, we have 22. That's the next palindrome, right? Up all the way to 29, that's also going to yield 22. If we iterating to this number 30, we have 33, right? So what is the key observation here, right? We can generate a sequence of palindrome by basically just iterating through the number and mirror the first half of the number, right? And what is this? One more thing is that the larger the number, the greater the palindrome, right? As you can see here, the larger the number, the greater the palindrome is, right? So that's two things. We can generate a sequence of palindrome by iterating through number and mirroring the first half of a number. And the greater the number is, the greater the palindrome is. So another question is that, can we just mirroring the number and return the result, right? This is a greedy method, right? Probably not. I've also like think naively like that, but probably not, right? Consider these two cases. If the number itself is a palindrome, then we return what? Itself, right? If we following this method, then we just mirroring the number and return itself. But if you guys read the description, then we need to return the closest integer and not including itself, which is a palindrome, right? So we cannot return this. And another case is this guys, right? Now, if we're going to mirror it and return it, and it is a wrong answer. Why? Because basically there's a palindrome that is 99799, which is closer to 99800 than this one, right? So what does it suggest? If you take a hint, do we have to consider only left half or right half of the string or both, right? So the answer is we must take consideration of both the previous lower palindrome or the next greater palindrome, right? And since we can basically generate palindrome using this method, and since the greater the number is, the greater the palindrome is, can we use binary search to optimize the search? And the answer is yes, right? So we going to search for the previous lower palindrome, and we're going to search for the next greater palindrome, right? So for the lower palindrome path, we will define our search space from 0 to n, and we construct the palindrome for the midpoint. And if it's smaller than n, right? If it's smaller than n, then we have found our candidate. This can be that palindrome, right? This can be the result. And since it can be the result, and we need to keep looking for a potentially greater palindrome that's lower than n, we move L to mid to keep searching for that candidate, right? Else we know that anything larger than if the palindrome that we construct for the midpoint is actually larger than n, right? We need to do what? We need to lower our search space. We need to keep looking on the left side of the search space to potentially generate a lower palindrome than n, right? A palindrome that is smaller than n. So we move r to mid minus 1 to like just totally eliminate these guys, right? And the same thing, basically search for the next greater palindrome. But here's what's tricky about this question is that how can we define our search space? Basically we have our lower bound is n, right? We search for from n to what? So basically any upper bound that's going to yield a palindrome that's larger than n is fine, right? We can use a fixed bound like these things, right? Because the constraint told us that n is from 1 to these guys, right? So we can fix it, or we can use a dynamic one like 2n is okay, because 2n is always going to yield a palindrome that's going to be larger than n, and it's pretty long to prove that, so just leave it behind. And if you guys feel it's a little bit weird, then you can use this fixed bound, right? It's up to you. So we construct the palindrome for the midpoint. If it's larger than n, then we found our candidate, right? So we move r to mid, else we move L to mid plus 1, right? Okay, so finally, if there's a type, return the smaller one, right? We compare the distance between the previous lower palindrome and n, and also the next greater palindrome and n. And if the distance are the same, we return the previous lower palindrome. else if the distance just if the distance is 2 and 3, we just return whatever u3, right? Basically that. So basically that's how you guys are going to solve this problem. So now let's go to the implementation part, and believe it or not, the implementation after is kind of long and tedious. Just bear with me, right? So now we need 4 method actually. One to construct the palindrome, one to find the previous lower, right? This is going to take and put this string, return integer, find next greater. Okay, so now let's okay, so for this guys, and we're going to call 2 variable, call the previous lower palindrome, which is equal to cell.find previous lower, and the next greater palindrome is called self find next greater, and right. And now we need to calculate the difference between them, right? So since this guy is going to yield an integer output, then we just basically do this. If n minus previous lower palindrome is smaller or equal to next greater palindrome minus n, right? So we're just going to return string previous lower palindrome, else we just return string next greater palindrome, right? Okay, so now we will write our construct palindrome method. How we going to do that? So as I've said, there are basically 3 possibilities, right? If the length of the number is actually smaller or equal to 1, which is basically return itself, right? So if length n is like this, return n int n. If then okay, let's do this. If the length of number is odd, is even, right? Now we can just mirror. We can just take the first half and concatenate it with the second half, with the first half, but reversed, right? Else, if the length of the number is odd, right, we just return basically the same, but for the consider this guys, right? We need to take onto, and then we need to revert this guy, right? Okay. So we're basically going to do, rather than taking up to only n divide by 2, we're going to take n divide by 2 plus 1, and then just take the first half and reverse. Okay. Let's going to make sure it work correctly, and we're going to do pass. Okay, so we get 1 to 1. I think that's correct. Get let's include an even length, and then also if the length is 1, right? See it work correctly. Yep, okay. So now we have our construct palindrome. We're going to do our 5 previous lower. So as I've said, then we need to define our search space from 0 to n, right? So left right is equal to 0 to let's call it int, and then okay, so we can basically just do this, right? And then y l smaller than r, our mid is l plus r plus 1 divided by 2, and if a cell construct palindrome, our construct palindrome will receive a parameter of type string, right? So this guy is actually integer, so we need to convert it. String mid, okay, is actually what is smaller than n, right? So we found our candidate. If we found our candidate, when what we're going to do is that we're going to shift out search space to the right, so to potentially find a greater candidate. Such else go to mid, else then we just going to lower our search space, and in the end we just return what? Self-construct palindrome string l, right? So to make sure it's worked correctly, and we're going to print self reverse lower 1 to 3. Okay. Okay. Sure. Okay, so we have 1 to 1. Let's try to search for 1 to 1. If itself is a palindrome. Yep. Okay, that's work, right? So now we're going to write our find next greater method. Our search space will be from n to. You can do this. You can do this. You can do this. Whatever you like, right? Okay, so y. So if self-construct palindrome is larger than n, and we found our candidate, right? But basically we need to find the next greater palindrome. So instead of looking to the right, instead of moving our search space to the right, we need to move our search space to the left, right? Else, which is going to do else equal to 8 plus 1. Basically, if the construct palindrome for the midpoint is actually smaller or equal to n, then we need to move our search space to the right to find a greater palindrome, a palindrome that's greater than n, right? And we just return self-construct palindrome string l, right? To make sure this guy worked, and okay, let's do it. Print self find next greater to 1. Right? This guy is going to take an input of type integer. Okay, so we have 1 1 and 1 3 1 for 1 2 1. So I think it's work right. Okay. So we need to previous lower palindrome is called self.find previous lower. And this guy take an integer, a parameter n of type integer. This guy is actually string, right? So we need to convert it to integer. Also this guy. So these two guys are going to yield an output of type integer, right? So this is correct. This is correct. Let's just run it. String and int. This guy is actually a string. Okay. So we need to convert it to integer. Okay, let's submit it. Okay. This method is actually not that efficient compared to other type of method that use purely math. Right? That use purely math is not going to be more efficient than these guys. Let me show you. Okay. 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 Such as these guys, or actually pretty short. I don't know. Okay, so whatever the time complexity of this solution is, we're going to need to find our previous lower, which is going to run from 0 to n. That's going to be log of n, right? And inside these guys, we're going to do our self.construct palindrome method. This is actually O1, so we don't really need to care about it. So this guy is also going to be log of n. Since our source space is n, right? We take 2n minus n, that's n. Okay, so that's 2 log n, right? Out of 2 log n, which basically is O log n if we reduce it, right? And for the space complexity, it's going to be O of 1. We basically only need 2 variable, right? We are going to need 2 variable, and that's it. For this guy, we will need 2 pointer, and this guy is also 2 pointer, so that's just O1. Okay, so I hope that's you guys understand what I'm talking about, and I hope it makes sense to you guys, because I think this problem is probably lead more toward the harder side of Leetcode. I have done like basically daily challenge for the past 2 months, and this thing is actually the hardest out of them, and it also has the lowest acceptance rate. Yesterday, the acceptance rate for this solution, for this problem, is actually 20%. So don't feel bad if you cannot digest the logic behind it, because I have to skim through the discussion section a whole lot before having enough intuition to actually solve the problem. Okay, so see you guys later, and thank you for watching.